everyone, my name is Ainul, and in this video I will share about the Fourier transform technique in Tropospheric Emission Spectrometer TES of the Aurora satellite. So, out of all the topics that I could have chosen for Fourier transform application, why did I choose the Fourier transform technique in the TES of Aurora satellite? Well, we see that Fourier transform is a robust application in our modern world, and one of the applications is image processing, like in our smartphones and digital cameras. But how about we step a little bit further from our Earth atmosphere? That is where we can find the NASA Aurora satellite. And one of the instruments is the NASA Aurora satellite is the Tropospheric Emission Spectrometer, or in short TES. So what exactly is TES? Well, TES is a high resolution infrared imaging Fourier transform spectrometer that study the Earth troposphere by measuring atmospheric gases like carbon dioxide, methane, and nitrogen dioxide. Before we dive deeper into how TES apply Fourier transform, we need to know what is Fourier transform. So basically, Fourier transform is a mathematical technique that transforms a function or a signal from time domain into frequency domain. It decomposes the signals into a constituent frequency, which then provide a powerful tool for analyzing its spectral content of signals. So Fourier transform is given by capital F of omega equals to integration from negative infinity to infinity of f into t times e to the power of j omega t of dt, where omega is the frequency and t is time. We also have inverse Fourier transform, which is function to revert the Fourier transform signal into its original time domain signal. Other than that, we also have fast Fourier transform and discrete Fourier transform. Now, how is Fourier transform is applied into the TES? Well, first, TES collects an interferogram, which is an analog signal representing the interference pattern created by the Michelson interferometer. This pattern results from the varying path lengths of the split infrared beams. Then the interferogram, which initially exists as an analog signal, is converted into a digital signal using an analog to digital converter (ADC). This conversion is necessary for the data to be processed by digital computers. The next step, this is where the Fourier transform comes in. We know that Fourier transform is the integration from negative infinity to infinity of f of t times e to the power of j omega t. By using this formula, the digital interferogram collected is processed using a fast Fourier transform FFT algorithm. The FFT is a mathematical technique that converts the time domain signal or data into frequency domain data. This results in a digital spectrum representing the intensity of infrared radiation at different wavelengths. So I guess that is all about the basics on how TES Aurora uses Fourier transform to produce the final TES data products, such as calibrated spectra, gas concentration profiles, and temperature profiles, are provided in digital formats that can be accessed and utilized by the scientific community and other stakeholders. That's all from me. Thank you.